Hello, friends, welcome back. I am Rajneesh, and today's episode is about distributed lock management and clustered LVM. So, let's forget about the word distributed and let's talk only about the lock management first of all. Lock management is a facility which is provided by the operating system that makes sure that one particular file is written only by one particular process at any instance of time. Why do we need it? For example, we have application A or process A that opens a file, writes to it. At the same time, process B opens it and writes something different to it. And now A closes the file, B closes the file. So as A closed and write to the file first, and B writes to the same file after that, because initially both of them had the same data, and after that they modified something different. A added 3 lines 1 to 3, B added 10 lines B1 B2 till B10. So as A closes first, the file becomes whatever contents A wrote to it, and after B writes to it, the file written by A is overwritten, and finally you have an inconsistent data. The data that was written by A is completely lost, and the thing that is visible is corresponding to B only. So it says that in case there is no lock manager is present, you may have inconsistent data. So there must be some kind of locking mechanism which makes sure that in case any process is has opened a file in write mode, no other process should be able to write to it. This is lock management. Let's talk about distributed lock management now. Distributed lock management actually means that if you are talking about multiple nodes in a cluster and any application is trying to modify anything, the same modification or same lock should be propagated to all the nodes. So all these nodes know which process is trying to write to which file. So finally it means that it synchronizes your access to the shared resources. Okay, if we talk about distributed lock management or DLM, the entity that DLM knows is resources. It's not a file, it's resources. It understands your IP resource, understands your cluster service resource, it understands your file system, it understands your CLVM, it understands your service. So let's talk about resource group manager, which is responsible for running a cluster service and relocating a service from one clustered node to another. Now, distributed lock management is the service DLM control which runs on all the clustered node and makes sure or which has the complete details of which service is running on which node so that it doesn't run on multiple nodes at the same time. So when you are talking about RG manager, it starts a service or allocates a resource to a particular node. It notifies DLM of the same, and DLM knows this services and or resources are now allocated to node 1. When the service is relocated from node 1 to node 2, distributed lock management removes the lock corresponding to node 1 for the clustered services and clustered resources and assign them to node 2. And finally, DLM on all the three nodes is notified of the same. And finally, all the nodes 3 know that clustered service is running on node 2. So this is how resource group manager works. Let's talk about global file system. Global file system has a facility that allows multiple nodes to mount the same file system in write mode. And if you are talking about the same file system which is mounted by multiple nodes, so there should be some kind of mechanism which tells every node that this file is being locked and this node is working on it, and this node has opened it in read write mode. As we are using the shared storage or shared LUN, the same is accessible to all these three. Same folder is mounted to all the three nodes, and I am trying to modify, for example, var.html index.html from node 3. So distributed lock management comes to know that var.html index.html is being written by user XYZ on node 3, so at the same time notifies node 2 and node 1 of the same. So node 1 and node 2, in case they try to open the same file, they'll come to know that this file is being opened or is opened by some application on node 3. So to keep it consistent, you should not write to it. Let's talk about CLVM now. This actually has the clustered extensions of LVM2. What are the clustered LVM extensions? By default, if we talk about LVM2, it has the locking type of file which says, in case I am trying to do something on, if I am trying to modify something on volume group logical volume manager, it will have a lock using file which will prevent any other action from being happening on that particular volume group. So as an example, I'm trying to run one command which says lv resize increase the size of logical volume lv1 by 100 MB. At the same time, I run another command which says remove logical volume lv1. It could read it could lead to the inconsistent data in case there is no locking available, because how will you come to know whether we have to increase the size or remove it? Maybe it happens one is trying to increase the size, other tries to drop it. So finally you have inconsistent data. That's why lock is required for LVM. Now, if we have a lock using file based locking, node 1 knows that someone is running the command using LVM. Someone is trying to modify the volume management or LVM2 metadata. But node 2 has no information about this file because this file is present on node 1. So that's the reason we make use of clustered LVM. Here we come. So there is a service CLVMd which runs at the back end and make sure that the lock is actually your clustered lock, which is visible to all the nodes in the cluster, and it does it with the help of distributed lock management. So in case you are trying to modify something related to LVM2 metadata, all the nodes are aware of that modification, and the same at the same time, if node 2 tries to modify anything, it won't be able to modify because node 1 has created or has received a lock from DLM which is visible to all the nodes in the cluster. And till the time LVM2 metadata is modified by node 1, none of the nodes in the cluster can modify anything on that particular volume group. So it provides a volume management of cluster storage. It's actually a cluster wide implementation of LVM. It uses lock management or distributed lock management service to that is provided by the cluster infrastructure suite. CLVMd distributes LVM metadata updates in cluster and provide cluster node with same view of logical volume. So coming on to the labs now, I click on it. Is my cable fine? Okay. So let me just bring it to full screen now. Okay, so in continuation with the last lab, we have switched off Lucy. Why? Because in this lab we are not going to modify anything in the cluster configuration. The only thing that we are going to do is we are going to understand the implementation of CLVM. For that we need to have clustered nodes, and we have two nodes, node 10 and node 11, that have already been configured, and these machines are switched on. Now CLU stat is the command that I can use to check out the status of the cluster. The name of the cluster is my cluster. Member status is correct, means the cluster is working fine and all the clustered services are running. Member names. How much members does this cluster has? Right now it has two members, node 10 and node 11. Status online simply means cman is running on them or the cluster manager is running on both of them. Here you can see an RG manager says resource group manager is running on both the nodes. So the services have the facility to be migrated to the other node in case one goes down or gets hung due to any reason. Local means local is node 10, means I am running this command from node 10. Here you can see the clustered services. My web cluster is the name of the clustered service, and node 10 is the node on which this service is running. For example, httpd status. So Apache is actually running on node 10. The virtual IP is assigned to node 10. File system is mounted on node 10 and the script is running on it. So that's why this, and uh, to say it overall, actually the cluster web service is running on node 10. Okay. Now coming on to our LVMs, LVS, to display the details about the LVMs. Let's grab to test LVMs out of it. Test and test LVM. Now what am I going to do? LV remove dev vg0 and test VM. Now it is asking you whether you want to remove the active logical volume. I am not going to answer it because I want this command to stay for some time so that we can see how the locking works. LV, okay, I'll try to remove any other volume, not this one. Now I'll be using test. This time it was test VM, dev vg0 and test. So here this command is stuck. Why? Because there is already a lock file which is present, and which is var lock vg0. We have a command lsof that can be used to check out which is the process which is using this file, and here we can see that the process ID is 20372 ps-ef and grep this one. We come to know that this is actually lv remove dev vg0 test vm. So actually this process has taken a lock which is var lock lvm v vg0. So it has taken a lock and it will not allow other lvm command to be run on it. vgs. Why? Because we have a file based locking. To make sure that no more than one applications take a lock and try to modify the LVM metadata, we need lock. So just say no and come out of it. Here we can see that the locking type is 1, the base machine, and locking type 1 says you are using file based locking. That is, this file where lock LVM VVG0 was created, which was a simple file. It works fine as far as you are managing the logical volumes on a single node. But if we are talking about clustered environment, all the nodes in the cluster should be notified of this lock. So that's the reason we would be using lock type 3, which is built-in clustered locking. There is one more option, which is 0, which says that there is no locking mechanism, but it can lead to the corruption of your LVM2 metadata, because two commands may try to write to the same volume group and it may become corrupted or inconsistent. So the thing that we have to look into is type 3, which provides clustered locking. Now we come out of the base machine because we know what a file based locking is. Slash etc, okay, fdisk minus l dev mapper, okay. Now first thing I'll tell slash etc lvm lvm.conf to make use of locking type 3, which is corresponding to the cluster, so that it will try to create a clustered lock rather than a file based lock. lvm lvm.conf, locking type is 3. Second thing we need to make sure is distributed lock management should be running, which tells everyone of which is the lock which is taken. Minus ef grep minus I DLM control. So it's present on both the nodes. Perfect. Now the final thing that we need to make sure is whether CLVMd is running or not. So it's stopped. We need to make sure that CLVMd should be running. In case CLVMd is not working, it will not be able to get the lock corresponding to the cluster, and finally it will make use of the local lock, and it could happen that both the nodes try to modify the same volume group and may lead to inconsistent data. I'll show you an example. So if I type pv display command, here I can see, okay, here it says you connect failed on local socket, no such file or directory. Internal cluster locking initialization failed because CLVMd is not running. It was not able to obtain a cluster wide lock, so it fails back to local file based locking. Simply means that it's not able to take the global lock in the cluster. So in case I am trying to modify the same thing, the other cluster nodes will not be notified, and they may also run the same commands, or they may try to modify the LVM metadata, and LVM metadata may become corrupted. So make sure that CLVMd is started, chkconfig CLV on. Now if I type the command pv display, it'll let you know which all are the clustered nodes on which CLVMd is not running, because until CLVMd is running on node 11, it cannot understand the locks. So it's not able to obtain a global lock because node 11 is not notified until CLVMd is running on it. CLVMd start, CLVMd on. Now if I try to type the command PV display, it works fine and we have received a global cluster lock this time. Fine. Now we are going to create a new logical volume which could be LV cluster. Before that, let's create mapper. Now I can see that it has two partitions, P1 and P2. I am going to create a new partition, primary 3, start from 60 is fine, size is going to be 200 megs. I write and quit. Now dev mapper, here we can see that partition 1 and partition 2 is visible, but the partition 3 is not yet visible. Let's run the command path probe. There is a warning which says that is the first partition is already used and the second partition is already used. So that is fine, but we have received dev mapper, the third partition which is required by us. Let's run the path probe here also, and now you can see that you have all the three partitions, partition 1 2 3. I need to do one more thing. Type coming back to node 10, print, let me change the type of the third partition to the LVM, which is 80. Print partition, uh, sorry, it's 8e. Type 3 8e, print. So it's now LVM. Write and quit. Now uh, let's run path probe to get the details of the new partition. Let's run the same over here. Fine. Dev mapper, here we can see all the three partitions. Now if I run PVS or PV display, I can see only one physical volume which is corresponding to its local disk or direct attached disk, and PVS over here displays the local disk. Now I am going to create my first physical volume, dev mapper cannot open exclusively mounted file system, so someone is using it. Let's forget about it now. We created a new partition which is P3, so we are going to use this one, PV create. So here we can see that the physical volume corresponding to third partition is created. PVS displays that you have this as a physical volume. We are not modifying anything on node 11, but if we run the command PVS, we can see that the same physical volume is now visible on the node 11. Why and how did it happen? This is all because of the presence of the service CLVMd, which is running on backend. Let's create a cluster, VG create VG cluster, dev mapper P3 VGS, and here I can see VG cluster now. I didn't modify anything on node 11, but if I type command VGS on node 11, I can see that VG cluster is now propagated over here. Let's create a logical volume of 100M minus LV cluster is the name in the volume group VG cluster. And if I type the command LVS, I can see that new logical volume LV cluster is created, the size of which is 100 megs. If I write LVS command on node 11, I can see LV cluster is created over here. Now this is ready. mkfs.ext for dev mapper, dev VG cluster and LV cluster. Now this clustered logical volume is ready to be used on any of the clustered nodes. For example, we have formatted it on node 11 and we'll try to mount it on /mnt, and I was able to mount because whatever modifications I am doing are visible to all the nodes in the cluster. So let's try to remove it. umount /mnt. Let me create one more logical volume inside it. lv create minus l plus 50m minus n, name lv cluster 2 from the volume group VG cluster. Now we have two logical volumes in the cluster, LV cluster and LV cluster 2. Let me try to remove it. LV remove dev VG cluster LV cluster. It's stuck. Fine. Now I am on node 10 and I'll try to remove the another clustered logical volume, and you'll see that it's stuck because it knows that node 11 has already taken a global lock for it. SSH node 10, so it's actually checking out the status of Apache. So here you'll see that it won't be able to remove it because the lock is already there. So as soon as you release the lock by saying yes or no, it comes to know through a distributed lock management that the lock has been removed, and now it will ask you whether you really want to remove LV cluster 2. We can just say no. So this is how a distributed lock management and your CLVMd interact with each other and inform each other that this particular modification is being done on a particular volume group or a logical volume, and they acquire a global lock for it. So yes, we have so this is all for distributed lock management and clustered LVM. In the next session we are going to continue our discussion with global file system. Thanks for viewing the video. Have a good day.